The x and y intercepts of a graph are where the graph crosses the x-axis or the y-axis. Here you see a picture of 4 different graphs. The first one has 3 intercepts. Its x-intercepts are there and there at 2, 0, and negative 2, 0. It has a y-intercept there at 0, negative 4. The line has a y-intercept at 0, 6, and it has an x-intercept at negative 3, 0. The parabola on the bottom only has one intercept. It has a y-intercept at 0, 10. The graph on the right has no intercepts because it starts in the first quadrant and goes up and to the right, never crossing the x or y axis. So you can see that a graph may have 0, 1, or more intercepts. You'll also notice that on all of the x-intercepts, the y value is 0 at negative 2, 0, 2, 0, negative 3, 0. So for the x-intercept, the y value always equals 0. For the y-intercept, it's the opposite. Here at 0, negative 4, you have a x value of 0, same with 0, 10, and same with 0, 6. So the x value is 0 when you're talking about the y-intercept. Because we know this about the intercepts, that one of the values has to be 0, it allows us to solve and find the x and y intercepts even if we're not looking at the graph. For instance, this first equation, y equals x squared minus 4, is the equation of the top left-hand graph. If you plug in x equals 0, you will find the y-intercepts. So if I plug in 0, I get 0 squared minus 4, so y equals negative 4, which gives us our point of 0, negative 4, which is what we saw on the graph. Similarly, if we plug in y equals 0 and solve for x, we can find our other intercepts. So 0 equals x squared minus 4. You can add 4 to both sides and get 4 equals x squared. Square root both sides, and you get values of plus or minus 2, because 2 squared and negative 2 squared are both 4. So we have 2, 0 and negative 2, 0 as our intercepts. The equation y equals 2x plus 6 is the equation of the line, which was the top right-hand graph. If I want to find the y-intercept, I'm going to plug in x equals 0. So y equals 2 times 0 plus 6. So y equals 6. So my intercept is 0, 6. If I want to find the x-intercept, I'm going to plug 0 in for y. 0 equals 2x plus 6. Subtract 6 from both sides. Negative 6 equals 2x. Divide by 2, and negative 3 equals x. So our intercept is negative 3, 0, giving us our 2 intercepts that we saw on the graph. This is the equation of the graph on the bottom left. If I want to find the y-intercept, I'm going to plug in x equals 0. So y is equal to negative 3 squared plus 1. Y is equal to 9 plus 1, which is 10. So that gives us 0, 10, which is the intercept that we saw. If we try to plug in 0 for y, 0 will equal x minus 3 squared plus 1. Subtract 1 from both sides, and you get negative 1 equals x minus 3 squared. We cannot take any number and square it and end up with a negative number. So this doesn't work, which is why there was no intercept there. This is the equation of the graph on the bottom right-hand side, and if you remember, it had no intercepts. It was in that top right-hand quadrant, didn't cross any of the axes. So if we plug in x equals 0, we're going to get y equals 5 plus the square root of negative 2. And we can't do that. We cannot take the square root of negative 2 and get a real number. So right there we run into a problem, so that means there is no y-intercept. Now the second part is a little trickier to see. If you plug in 0 for y and try to solve it, a lot of people will make a mistake here. If we move the 5 over, subtract 5 from both sides, we get negative 5 equals the square root of x minus 2. If you square both sides, you get 25 and x minus 2. So it looks like x should be 27. But if you plug 27 back up into the equation, you get the square root of 25, which is 5. And 5 plus 5 is 10, which is not 0. So this happens because the square root involved in the problem is the positive square root. Oops, there. It's the positive square root. It's 5 plus the square root of this, not 5 minus the square root of that. The 27 would be an intercept if the equation was y equals 5 minus the square root of x minus 2. So when you're working with radicals, it's a good idea to take your answer and plug it back in. Okay, so let's do an example. Let's say you're told to find the x and y intercepts of this equation. You start by letting x equal 0. So 2 times 0 squared plus 5y equals 20. So 5y equals 20. So y equals 4. So your first intercept is 0, 4. To find the next intercept, you're going to plug in y equals 0. So you have 2x squared plus 5 times 0, so basically plus 0, equals 20. 2x squared equals 20. X squared equals 10. Take the square root of both sides, and x is going to equal the positive and the negative square root of 10. You could get that decimal on your calculator, but simplest radical form is fine also. So that would mean your two intercepts are radical 10, 0, and negative radical 10, 0. Let's say you want to find the intercepts for this equation. Let x equal 0. So y will equal radical 3 minus 2. And that is basically simplest form right there. You're going to get a decimal if you plug in radical 3 to your calculator and subtract 2. So your intercept there is 0 radical 3 minus 2. If you plug in 0 for y, you get 0 equals the square root of x plus 3 minus 2. Add 2 to both sides, so 2 equals the square root of x plus 3. Square both sides to get rid of the radical, and 4 equals x plus 3. Subtract 3 from both sides, and you get x equals 1. So you have an intercept at 1, 0.